Okay, for this video, we are going to talk about Newton's three laws of motion. So to start off with, uh, Newton's first law of motion states an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an unbalanced force. And we will talk about that more here in a minute. Newton's second law states an object will accelerate in the direction of a net force, which also can be our F, our force equals m times a, or mass times acceleration. And then Newton's third law is for every action force, there's an equal and opposite reaction force. So to start off with, Newton's first law of motion is sometimes called the law of inertia. So inertia is an object's tendency to resist a change in motion. So the more inertia an object has, the least likely it will be to move or to change its motion. So to go along with this, the bigger the object, the more inertia it should have. And if you think about it, a car is a heck of a lot easier to push. Sorry, a car is a heck of a lot harder to push out of the way than a person would be. So if we look at these, so if we had a 20 kilogram object and a 5 kilogram object, obviously our 20 kilogram object here should have more inertia because it's bigger, it weighs more. There's more stuff in it to move than our 5 kilogram object. Newton's second law of motion. This is the one we are going to spend the most time on. So all that states is that an object will accelerate in the direction of a net force. So what we mean is if we have our generic box, we have two forces acting on it. We have a 5 Newton force pushing to the right, and let's say we have a 3 Newton force, which is going to be friction. We'll call this friction, is pushing against you as you try and push this box. So the net force acting on this box, because again, we're looking at the net force. So the net force on this box is going to be 2, because you need to take 5 minus 3 since they're on opposite sides. So this means your box is going to inevitably be moving to the right as you're pushing on it. We can also calculate this mathematically. So we can also say A equals F divided by M. And in this equation, A equals acceleration, which is measured in meters per second squared. F is a force, which is measured in newtons. And then M is mass, and it's measured in kilograms. So again, you have seen this equation before, or this triangle before, but it's because it's the same for F equals M times A. So this triangle is where we're getting this formula from. So if we were to cover up A, what we're left with is we're left with a force over a mass. So first off, let's look at our problem here. So you push on a 5 kilogram box with a force of 10 newtons. And since it doesn't tell us any other forces, we're going to assume that this is our net force. And what we want to know is we want to know what our acceleration will be. So again, you always need to write out your equation every single time you're given a problem. So A equals F divided by M. And when we look at this problem, our force, which is measured in newtons, is going to be 10. Our mass, which is measured in kilograms, is going to be 5. And so when we take 10 divided by 5, we get 2. Ooh, it should not be newtons. That is wrong. It should be meters per second squared, because we're looking at an acceleration. And if you remember, our acceleration is always in meters per second. I do not know where I was getting newtons from. Okay, next slide, or right underneath the next problem. So if you want to accelerate a car at 25 meters per second, and it has a mass of 1,500 kilograms, how much force is needed? So to start off with, we're going to try and find force. So we're going to try and find F. So if we cover that up, what we are left with is we're left with M times A. So force equals mass times acceleration. When we look through our problem, remember mass is always measured in kilograms. Acceleration is always measured in meters per second squared. So we should be taking 1,500 or 1,500 times by 25. And when you punch this into your calculator, you should get 37,500 newtons. And so that's how much force it would take to accelerate that car to 25 meters per second squared. Okay, with Newton's third law, for every action, there's an equal and opposite reaction force. So a couple examples of these. So if you're pushing on a wall with 5 newtons, the wall will inevitably push back in the opposite direction, so against you, with 5 newtons. It's going to match what your strength is unless you push the wall over. So with this example here, you've got your person, they're pushing 5 newtons to the left, so the wall is going to push back with 5 newtons to the right. Again, equal and opposite. The same thing is true for walking. So as you walk, your foot will push against the ground. And so the ground is actually what is pushing you forward. That is what's moving you forward. Swimming is the exact same way. You push back on the water with your hand, so then the water pushes you forward. So to kind of give you a picture of walking, they've got a person on a skateboard here in this image, but your foot is pushing down, and so the ground is going to push back and up. In this instance, it happens to be up. So, but you're still moving slightly forward there. So you are moving forward.